All right, guys, prime factorization is what we do today. We're seeing what things can multiply to make bigger numbers. All right, as we did the warm-up, good job. Good job. Yep. Uh-huh. And we will talk about what prime numbers are so we can figure out what those get to. Sorry I skipped over the first two parts quickly. We want to get here. Prime factorization of composite numbers. We'll talk about what both of those words mean because they're both important to this lesson. A prime number is a whole number greater than 1 that has exactly 2 factors. 1 in itself, 17. Oh, the only factors are 1 and 17. 3, the only factors are 1 and 3. All right. 11, the only factors are 1 and 11. That's the way you get a prime number. A prime number is a whole number greater than 1 that has exactly 2 factors. 1 in itself. A composite number, on the other hand, is a whole number that has more than 2 factors. Something like 4. 1, 2, and 4 all can multiply to get to 4. All right, 6 has 1, 2, 3, and 6. All right, those are all factors of 6. So composite numbers have more than 2 factors. Prime numbers have only 2 factors. All right, you can read that again. You can listen to it again, but you got to understand it. So let's see if the number is prime or composite. 11, the only factors are 1 and 11. 2 of them. So it is a prime number. 16. Well, there's factors of 1, 2, 4, 8, and 16. All of those will multiply to go into there somehow. There's more than 2 factors, so 16 is a composite number. All right? 14. We list out its factors. 1, 2, 7, 14. There's more than 2, so hopefully you saw that it was composite. Number 7, there's only 1 and 7. That's 2. That means it's prime. A composite number can be written as a product of prime factors. This is called prime factorization. A product of prime factors. That's prime factorization. Mrs. Letcher calls it the factor tree, as many other people do as well. That's probably what you remember. You can use a factor tree to show the prime factors of a composite number. All right. You can write prime factorization by using exponents as well. The exponent tells how many times they use the base as a factor. So, 24. We start there. We could go 2 times 12. That is one way to work it. Oh, 2 is a prime number. Then we got to keep going until we get all prime numbers. 2 times 6. 2 is a prime number. 2 times 3. 3 is a prime number. Once you get to all prime numbers, stop. So then, the prime factorization for 24 would be 2 times 2 times 2 times 3. Oh. You write them in numerical order from smallest to biggest. Or the way they said with exponents, 2 times 2 times 2 could be written as 2 to the 3rd power times 3. We did exponents way in the first days. Either this one or that one is an acceptable answer in my book. This will probably be more useful later on, but to know it can be written like that is probably a good idea. So let's look at what they did. They wrote 24 as a product of primes. They choose to go a different route. They do 8 times 3. All right? They keep writing down the numbers. There's no need. Stop right here. Circle. Prime number. Stop right here. Oh, 8 times 3. 8, 4 times 2. 2 times 2. Hey, they got 2 to the 3rd power as well. We don't need this extra googly gop. Just leave it like that. Okay? So, 2 times 2 times 2 times 3 is the prime factorization. or 2 to the third times 3. Okay? 150. On this one, I like to use 15 times 10 because it gets it down there quick. Then I can use 3 times 5. Circle the 5, it's prime. Circle the 3, it's prime. 2 times 5. Circle the 5, circle the 2, they're both prime. That means it's 2 times 3 times 5 times 5. All right? Or they could say 2 times 3 times 5 squared. And we can have either of those as our answer. Either this or that. Factor trees, hopefully you remember them. Even if you go a different way to break them down, you'll still get to the same prime factorization every time. They do 30 and 5. All right, remember, I don't like their method. Get rid of that. Don't need to keep writing that down. 30 will break down into, oh, that's prime. Don't need to write all that junk down. 2 and 5. Hey, 2 and 3 and 5 and 5. That's what we came up with. So when they do that, there's your prime factorization, or you can choose to write it with exponents. Either or is okay. 36, take a crack at it yourself. I like to think 6 times 6, 2 times 3, 2 times 3. Oh, they're going to write 2 times 2 times 3 times 3. Let's see if that's what they did. All right. Remember, prime number, we don't write all that. Prime number, we don't write all this. 2 times 2 times 3 times 3. We can write it like that. Or 2 to the second, 3 to the second. 90. 9 times 10. 3 times 3. 2 times 5. Prime number, prime number, prime number, prime number. That's where we wanted to be. They're going to write theirs out. Remember, all this googly gop out here we don't need. Oh. We got a prime number. We got a prime number. We don't need this down here. They got the same answers as us, so numerical order. All right. It should be 2 times 3 times 3 times 5, or 2 times 3 squared times 5. Because if you multiply those numbers together, you'll get back to 90. We are doing this so we can do reducing fractions easier in a little bit. That's why we're going over prime factorization again. You can also use a step diagram to find the prime factorization of a number. At each step, divide by the smallest possible prime number. Continue dividing until the quotient is 1. These can be confusing to people. I show them to you because last year I had a few gentlemen and ladies that really like this, and I want to give them that option. So here's what they do. 2 is the smallest one. That divided by 2 gets us down to there. Notice how 2 is red? It's a prime number. So the smallest number again is 2. So they divide by 2, get 119. Smallest number is 7. Smallest number is 17. Oh, here's all your prime factorization. Your multiplication skills have to be pretty strong to do it this way. I don't really care to. I like the factor tree. Okay? 275, they're going to divide by 5. Then they're going to divide by 5. They get to all prime numbers. Your prime factorization is 5 times 11. And 5 squared equals 11. Or 5 squared times 11 is your answer. One more just for the kicks of it. Divide by 2, divide by 2. Maybe? All right. They do it for a long time. Divide by 3, that's 27. Divide by 3, that's 9. Divide by 3. You got your whole prime factorization here. 2 squared times 3 to the 4th power. Or you can write it out long like that. All right. One more time with this, I think. 5 squared or 13. Now, there's only one prime factorization for a given composite number. Every one only has one. All right? 476 divided by 2, the smallest one. And then they began dividing by 2. If we do it a different way, we will come up with the same answer. I don't like 476 because it's just too big of a number. So let's use 81. No, let's use 36. 36. I could go 6 and 6 like I did prior. Then you get 2, prime number, 3, prime number, 2, 3. You get 2 squared times 3 squared. Okay? Or I could do 2 times 18, prime number, 2 times 9, prime number, 3 times 3, golly, 2 squared times 3 squared. You could also start with 4 and 9 and get there, but every time you do it, you get 2 squared times 3 squared. 2 squared times 3 squared, and you get your answer. All right, prime factorization's on the docket. I need to see the work. Talk to you guys later.